And as you can see, it like gets nicely clipped and it's like cool and stuff. So hello everyone, welcome to this cool video in which I'm going to show you the funny project that I'm well, just me fucking around, to be honest, not really a project. But the point is, this is a cube. It looks like a square, but it's a cube, trust me. And here we have a bunch of cool functions that do cool stuff. And here I have the functionality that I've been trying to implement for too long, but it's basically a triangle clipping. So we can clip the triangles because, you know, it's good, that's what you do. Here I have some other functions. Here I have the triangle filling. It's simply a scanline filling algorithm because it's simple. Here we go. That's our cube. Let's move it away so it wouldn't clip just yet. We can rotate it around the z-axis, and it's gonna look like this. Very nice. We can rotate it around the y-axis, and we don't sort any polygons in any way, so that's why you can see through stuff. That's not supposed to happen, but it is what is currently happening. So we can rotate it like that. It's very nice. It's very rotatey. And we can rotate it around the x-axis, y-axis. We can like do all sorts of cool stuff around the z-axis and like, there we go. It works. The thing that was a bit of a bane of my existence is triangle clipping. It's basically where we do this. You can kind of see it, but I'm gonna rotate it. You can notice that this triangle right here becomes a quad, basically, right? It's actually gets split in two. I bet I could demonstrate that. So here you can really see, like, when the triangles get clipped, you can see that it actually is two triangles. It gets split in two. It's a bit of a mess, but you can notice that it's what's happening. There we go. So here we can change the clipping distance, and you can really notice. So here is one, here is the other, and we can like basically clip very far. And we can just like basically, boom, the entire just cube disappears. So we can just change our clipping range. We can, if we get too close, obviously things start to go bad. That's why it's actually set to. We could set it to actually like 2.5, I think. And as you can see, it like gets nicely clipped and it's like cool and stuff. This is actually kind of a cool shot. Oh, that is. 2 is damn great looking. Damn, look at this. Let me, and there we go. Here's like the perfection, kind of a perfect resolution for this render. And here you can really see a bunch of stuff happening. Here you can see that, oh, this looks interesting. I don't think this is supposed to be get clipped. I think it's getting clipped there somehow. Oh well, the point is, this triangle is clipped. It's now a quad. This triangle is clipped. It's now still a triangle. This triangle is also clipped. This triangle is also clipped. Like it, you can very much see which triangles are clipped. That's very cool looking. I like it. This one is not supposed to be clipped because, well, why would it? But it still seems to be. I like the colors. And the colors are being chosen in the render function just for debug purposes. That's why we have to deal with this. But yeah, this is very cool. You can see that we can like, this is low res and that's for like real time rendering. And this is like, when we press R, it gets like super very good quality render. So the thing about Scratch is, movements are very expensive. Mathematics is extremely cheap. Movements are very expensive, and setting variables and like doing, like if we set a variable, if we change a variable, especially if we add something to the list or read something from the list, it's going to be very expensive. And movements are very expensive. I will say the most expensive operation is still touching color and touching something. Touching is ludicrously expensive in Scratch. You should never at any moment use this shit. If you want something to run fast, if something 3D related, never ever use touching, because it's bad. Especially this function, color touching color, that's just... But here you can see that it like scan lines exactly that, you know? There we go. It like does no, here's the bug that I see. Interesting. But basically, that's our scanline algorithm, right? That's how it works. It scans from top to bottom, left to right here, but it doesn't matter which way. But basically, top to bottom, and its scan line fills the triangles, right? That's how it works. But it's not particularly optimized for Scratch, because in Scratch we can set the pen size color, and we can change the pen size color. I've seen an algorithm that fills the triangles very quickly, very efficiently, but honestly I don't understand the math behind it at all. Or I didn't really look up the math, or didn't try to understand it in particular. Yeah, obviously there is no depth filter, depth sorting, but whatever. It works. Clipping works. It's cool. It's a cube. And we actually could place multiple cubes to rotate. There we go. Here's we have magical cubes. So I'm gonna try to upload the project to Scratch so you could actually check it out. And yeah, that's about it. And goodbye.